Welcome to qnawire.
All right, for this problem, all right, so we have this PV diagram, and this is isothermal process, so that the temperature is a constant. So the part is we want to find out how many moles of gas are involved. Uh, so we can notice that the state B, we already know the pressure and the volume, so we can start from this point. The PV equal to nRT. And this we are looking at this state. So this is just the PB, VB, and RTB. So we can figure out N equal to PB, VB over RTB, right? So PB is 0.2 atmosphere, and you need to transfer this into Pascal. VB is 0.1 meters cubed, and R is a constant. TB is given as 85 Celsius degrees. 85 Celsius degrees is 358 Kelvin. 358 Kelvin. Okay. So just plug in the numbers, and you'll see that the number of moles is 0.678 moles. And part B, we want to find out the work uh, done by the gas in process A to B. Oh, sorry. Right. Yeah, we want to find out the volume. Yeah, we want to find the volume at state A. So the volume is we simply need to utilize this relation again. PA times VA equal to nRTA, right? And VA is the volume at state A, is going to be nRTA over PA. And N is the one that we found here. TA is the same, 358 Kelvin, and PA is given as 0.6 ATM. I just write here, 1 ATM equal to 1.01 times 10 to the fifth Pascal. The Pascal is the standard unit. So the final result is 0.0333 meters cubed. Okay. And part C is we want to find out the work done by the gas in this process. Because this is the isothermal process, so the work is the work is actually, according to the definition, PdV, and P is simply nRT over V, right? This comes from the state equation, PV times nRT, and because T is a constant here, so we can move the numerator out of this integral. Equal to nRT times 1 over V dV, right? So equal to nRT times log Vf over Vi. And this log is a nature log. So we already know the number of moles, we know the temperature, and we know the R constant, and we know the initial volume, which is this one, and we know the final volume. So we can calculate this result directly. Let me see. Let me use the calculator and see how it is. N is 0.678 times 8.314 and times the temperature is 358 times so initial temperature is this one, and final temperature is 0.1. So it's basically 3 log 3. Hold on. 3 times 0.314 times the temperature. Temperature is 358. All right. So the final solution I got is 2,217 joules. Okay. And for part D, so we want to find out the change in internal energy. But this is isothermal process, so T is a constant. In that case, that is 0, because the internal energy only rely on the temperature. If temperature does not change, then the internal energy does not change. So that is 0. Okay, that's it.